Okay. Hey, I think there are two people in here. I think Oliver and Collaborator Vision, who I don't know who you are. Apologies if I should, but I'm hoping that you can hear me. This is all the first time I've ever done this, and I don't really know what I'm doing. So this could be a lot of fun, or it could be a complete disaster. But one way or the other, we'll see. This might be something I never do again. It might be something I do a bit more regularly. We're just going to sort of hack around with some code for half an hour, 45 minutes and see how it goes. I do have the chat and stuff open on another monitor, so please feel free to ping me if you have any questions or just to let me know if you can hear me. That'd be great. And I'm just going to kind of get going and we'll keep an eye on the chat and who is popping in or not. Cool. This feels very out of my comfort zone, but let's give it a go. I'm also hoping you should be able to hear some very faint background music. It is DMCA free. I managed to figure that out. So hopefully that's useful. But again, this is kind of feedback for me. If any of this is working well, is not working, it's too loud, too quiet, text is too big, small, anything like that, I really am as novice as it gets at this point in time. Okay, so I'm going to dive in. The library that I've been working on for a while now is this library called TestDataBot. And what TestDataBot does is it lets you build generators for objects such that you can generate test data. It's heavily inspired by this library called FactoryBot, which is a Ruby equivalent. I say equivalent. Ruby FactoryBot has been around for a lot longer and is far more established. But this is kind of, you can have these builders like this. Let me zoom in on that. You have this builder here. And then when we call it, we just get this user with a name of Jack. That's useful. It's not super exciting. Where it gets more exciting is we can say, okay, we have a field that is an ID, and that should be a sequence. And then every time we build one of those users, we get incremented sequence. So the first user will have an ID of 1, second will have an ID of 2. Then what you can do is you can be more generic here. You can sort of control what you do with that sequence if you want to. You can randomly pick between one of, if you have an option that's random between a few values, you can have the test data bot generate that for you. Similarly, you can have Boolean fields. And then you can also have this interesting per build field. And what that lets you do is every time you build, it will call this callback and you can generate some random data using something like faker.js, say. And it's pretty popular. I think it gets a fair amount of use, this library. It's got 600 stars, whatever that means, if that's good or not. And someone a while ago opened this issue suggesting that if you use TypeScript, you might be able to automatically generate these builders. So, for example, this user interface has 3 fields that are strings and 1 that can be admin or regular. They said this example where you generate automatically this builder when name description are call into faker. Now this is actually outdated. The code doesn't do this anymore. We don't ship faker, but we do still ship sequence and one of, and we could ship sort of a stub function for these. And so what I want to do, having played with ASTs in TypeScript quite a lot, I want to try and write an AST parser. So what I'm going to do is get TypeScript to give me the abstract syntax tree for some types, and then I'm going to see if I can generate the JavaScript code to create the builder. My picturing here is you have a CLI tool that lets you generate builders for a given interface. So what we're going to do is just kind of dive in and get started on that. If you've never played around with ASTs before, I think they're a lot of fun. I really like playing with them. There's this great website called astexplorer.net. And what you can do here is you can dump in some code on the left-hand side. On the right-hand side, we get the AST, the abstract syntax tree that represents this code. And this is what happens when TypeScript here compiles and parses this code. So we see we have this expression statement that represents this call expression, which is the console.log call. And then this kind of, you go down and down through this sort of tree that represents your code, right down here to the name. So you might be able to see there it's highlighting the log in yellow when I hover over this name here. And so this abstract syntax tree lets us navigate through the code and we can pull out the bits we want in order to generate the builder code for a given interface. So that's what I'm going to probably spend about half an hour, 45 minutes hacking on now, very much as a sort of test first stream I've ever done to see how this goes and see if this is kind of interesting or not. Just going to check for any tweets if anyone's telling me that I've configured Twitch incorrectly. Okay, it seems okay. Seems like I vaguely got it working. So I have cloned the test databot repo, obviously locally. I have it anyway because it's one I work on quite a lot. And I've created a stub generator file here in the codebase. And I've got going on the very fundamentals of the TypeScript parser. So what we're going to do, this generate here will take a TypeScript node. That's a node that represents some bit of code. We don't exactly know what yet. Logging it, and then we kind of generate for each child. So we're going to recursively go through this data structure. We may not need to do that, but this is an example. I then have some tests here in test generator. And what we do is we call this helper I've got called create TypeScript source file. That can just take some code and generate what looks like to TypeScript as an actual file that we can then parse. So it's a way of creating test code. So you see all that does is it creates a source file with some random file name and the code, and you tell it that you're targeting ESNext in this case. That's kind of by the by, it's sort of an implementation detail. And once we have this file, we can call the generate. That's my helper function here, and we can get some results. Now, right now, I'm not doing anything with this result, and I'm then calling t.ok, which is a way of asserting that a particular value is truthy, and I'm passing false, so it fails. The reason I'm doing that is just to kind of see what happens. If we run npm test, we can see that it does fail as expected. But what's interesting here is you can see the logs that are coming out from the TypeScript compiler for all the various nodes that we're working our way through. And so now our job is to start kind of going through those nodes and looking for the information we care about. This is a part of TypeScript that isn't particularly well documented. There is, if we go back to this, there is this using the compiler API page on the wiki. It hasn't been updated in a year. That said, it doesn't seem like it changes all too often. There's all sorts of examples here. The one I've gone looking for is this, traversing the AST with a little linter. And so what you can see is we go through each node and we can look at the kind of node to look for what is particularly interesting or not. And so what we want to do here is we're going to go through the nodes and pull out nodes that are of particular relevance to us. Now, if we go back to my text editor, I should say also this is NeoVim 0.9. I spend far too much time on my Vim configuration. It's something I've always enjoyed. I know some people absolutely can't stand that kind of thing. But if anyone has any particular questions about anything you see me doing, please just feel free to dump it in the chat. Okay, so I'm now going to change this code from being const.log to something maybe slightly more realistic. And so what we want to do in here is we're going to imagine we're generating a builder for an interface. So we'll define interface user. And in here, we're going to have name, which is of type string. In fact, let's go, yeah, that'll do. Let's do that for now. And so what I really want the code to be able to generate here is something that will look a lot like build user. And that's how we generate one of these builders. And then we'll open up an object like that. And it's going to say something like, what is it, fields. And we'll have name. And for now, I just want to put an empty string in there. That's kind of what we're going to target as our result here, something like that. I mean, the indentation is wonky because we're in a comment, but that's what I'm expecting here, something broadly that looks like that. When you're generating code, there's also the question of ensuring it's formatted nicely. I'm not going to worry too much about that for now. I'm just going to let it be formatted however it is. My usual approach here is to depend on a formatter such as Prettier. And so you generate the code that you want, then you run Prettier on it, which means that when you're generating it, you don't have to worry about nicely indenting everything and trading commas and single or double quotes and all that kind of stuff. You just leave that to Prettier. And we also need to figure out what this generate function is going to return. Like, what does this result actually look like? So what I'm thinking is we'll probably return some form of generator result. So we can define that interface. And it will probably have code, which will be string, and maybe success will be a Boolean. Something like that. In fact, you know what? Let's keep it simple. Let's just go code string for now, because I don't know if we're going to need anything more than that. Okay, and we will export that. We'll probably need that later on. So what we're going to now consider is how do we actually find this interface? And I should say we're going to need to generate the node, but we're also going to need to know the target interface, which will be a string. That's because if you've got a file with loads of interfaces in, the generator needs to know which one it should use which one it needs to generate the builder from. So that's what we're going to do. So now I'm going to need to update my tests, aren't I? To say generate file, and we want the user interface as our interface that we're going to target. So at this point, what I like to do is jump into the AST Explorer and again look at that particular code example. So we have interface user, and we know we're having a name which is a string. And now it's a little bit squashed here. Obviously, I've zoomed in and I'm not using all my monitor for the sake of making sure the code is a bit bigger on stream. But if we look here for this interface and we see we have an interface declaration. That sounds like something we're going to want to pay attention to. And it has a name, which is an identifier here. So its name will be user. That's not this name field. That's the name of the interface will be user. So that's how we can actually first find the interface that we particularly care about. That's fine. So I'm just checking. There we go. Okay, so the first things first is we'll try and pull out this interface by walking through the AST that TypeScript gives us. So we'll go back into here. So we're going to generate node and target interface. The first thing we need to do is actually try and find that node that represents the interface. And again, we know the type. If we go back to the AST Explorer, we know the type is interface declaration. So we're going to want to look for that. For now, I'm just going to code it in here, and I'm going to say switch node.kind, and it will be case, what is it, ts.kind. Is it ts.syntaxKind? There we go, dot interface declaration. There we go, nice. What I'm going to do now is just console log found an interface, like that. And we need to just update this recursive call so it passes in the target interface as well. So if I now run this, we get an error. Generator.ts, a function whose declared type is void, must return a value. I've missed the return. So let's just return for now code empty string just to have that parsing. Okay. And that needs a colon there. Okay, great. I'll get rid of this console log here. Found an interface. Okay, so we can see here that it does look like we at least are finding something. Something I'm just going to do temporarily is I'm going to go into my test command and I'm just going to give it test generator.ts because I don't want to run all the other tests that this repository has. So now we should just run one test, which we are. That should saves us running 30 odd tests every time that we're not working on. Okay, so once we've found the interface, we need to then check if the name is correct. And actually what I'm first going to do is I'm going to pull out this function called find target interface. And it's going to look very similar. We'll take the node that we're going to start with, which is a node, and we're going to take the target interface, which will be a string. And this will either find ts.node or null. And we're going to just literally take this code here and dump it into there. So if we find it, we need to now check the name and we'll recurse. If we get to this point, that means we haven't found it, we'll just return null. And so now what we can say in here is const interface equals find target interface node target interface. Lovely. And then we'll do something with that in a minute, which obviously we're not doing right now. So let's go back to the AST Explorer. Once we found this interface here, we need to look for its name, which will be an identifier. and when you can look at the name node itself, will have this property called escapes text. So that's what we're going to look at to see if it's the target name that we're expecting. So the name is going to be the node dot, was it name? I think it is name. Here we know the node is, so here's a problem. We know that this node is an interface declaration, but TypeScript doesn't. So what I can do here is I could say node as ts.interface declaration. I just saw a ts.is interface declaration, which sounds more like what we want. So the issue here is this case tells us that we have a node that is an interface declaration. However, in terms of the TypeScript compiler checking this code, it now isn't convinced that node is a interface declaration. It sees that it's just a regular node. That's not useful because now I can't call into properties or methods on this node that are particular to the interface declaration type. But what I can say is if ts.is interface declaration node, and now if I just type node here and look at it, we'll see it's now an interface declaration type. So TypeScript understands it, which means I should be able to say node.name, which is a field. And in here we will have escape text. So we can say if node.name.escape text equals the target interface, then we're done. We can return the node. If we're not done, what we're going to do is we're going to iterate through every child, because if it's not in this particular node, it might be in one of its children. We could probably be smarter and maybe not do this depending on the node type we do have. But for now, I'm early on in the project. I'm kind of at the get something working stage. So we're just going to do that. So now if we come here, what I'm going to do is I'm going to log out the interface that we have. And I'm going to run test again. Interface is a reserved word. That is completely accurate. So let's rename that to target inter. In fact, you know what? We're going to rename this target interface name. Then we can rename this to target interface. Okay, and let's run the test again. Interface null, so we didn't actually find it. So target interface, let's rename this target interface name. So what are we doing wrong here? I was expecting this to be equal. And of course, but we're going to do this. Yeah, so my return is getting lost. I'm not recursing this properly. Okay, so if we find the node, we will return it. That's fine. So what we can do is we can say let found node or null. So here we say found node equals node, and we'll do if found node here, return found node. That's the node there. And this needs to be equal null. There shouldn't be a node, it should be a TS node. Will that do it? I now get myself lost in recursive calls. Okay, there we go. Right, I got a little bit lost in how we do that. But now what we'll do is if the current node we have matches the name, we will return at that point. If not, we'll go through the children. If we find the node there, we will set it so. This is now, this loop is kind of inefficient because for each child is going to run, even if we have found the node, it will still check subsequent children. So to do, should break out of the loop here. And wow, that to do text is horrible. Not quite sure what's going on with that syntax highlighting there. I think the comment gray is messing with the white. Yeah, we'll need to fix that. Is there another one that's a bit less? There we go. Fix me is a bit less horrible. Let's leave that rather than to do, just for syntactical reasons. Hey, I can see there are a few people in the chat. Thank you for joining and watching. As I said, this is my literal first ever stream. So please feel free to tell me what is good and more pertinently what is bad, and if this is enjoyable or if this is a complete nightmare and you never want to watch it ever again. But I kind of figured I'd probably spend a few hours a week doing this kind of thing on my own, and I've found that I really enjoy watching people on YouTube and Twitch streaming, just seeing their workflows, how they kind of operate and debug and what their editor looks like, all that kind of stuff. And so the idea here is some people might find this a little bit interesting. I've just realized my head is over the code, so I need to remember to keep putting myself up. So please shout if I forget that. Okay, so now we have an interface. What I'm also going to do now is I'm actually going to use a Vim plugin that I wrote to run tests. It's called executor.nvim. And what I can do here is I can give it a command and it's going to run it. And it will tell me if it's successful or if it errors. So here we can see it says task errored. And I can look at the output here and we'll see that we expected a true value. Oh, it's Paul. Hey, Paul. So this is a Vim plugin I wrote where what I can do is I can run the tests in the background. If they fail, I get a little, it's supposed to be a cross, but it seems to be a plus on Windows. It's a cross on my work MacBook. But it would be a cross ideally, and then you can view the output. And the idea is what you then lets you do is it lets you go back and fix the tests. So we can change here false to true. And if we now run it, I'm hoping this will success. It is a success. You see we have a tick down there. And so you can run your tasks in the background and just be told if they are positive or negative. The idea behind building that plugin was that if the tests pass, I don't really care for the output. I don't really need to see it. It's only when they fail that they need to see it. So I like running them in the background and being told that I can then go and look at the output. Okay, so now we can find the interface. We should probably actually write some form of assertion here. So say something like, is it same in tap? T.same is deeply equal. I guess because it's strings, we can use equal. Is it equal? Yeah. So we're going to expect that the output is going to look something like build user like that, and then we're going to come in 2 spaces fields, 2 more, 2, 3, 4 name space, and we'll do trading commas like that. And this will be result.code. I think I've got those wrong around, haven't I? The actual one always comes first, I think. Found and then wanted, yeah. So result.code. Okay. So now what I can do is I can hit my keyboard shortcut to run those. You see we get a cross. It's unsurprising because this code definitely does not function correctly at the moment. I'm just going to pour myself some tea. Okay, great. So now we have the interface. What we need to begin doing is generating the list of fields we need to sort. So go back, whoops, not index, I want generator, source generator. So we have the target interface. If we don't, we're going to, so if we don't have the target interface, because at this point it could be null, we're just going to do that early return there. And again, let's leave a fix me. Should probably error here. We probably want to return the error saying that the interface couldn't be found in the long run. But honestly, again, at early stage of a project, I'm more about just making it work rather than kind of dealing with all the edge cases right off the bat. So now we have the interface. I'm also going to update this type definition because this definition is ts.node or null, but we know that it's an interface declaration. So I can actually replace this with interface declaration. And here again, I can say node is not node, it's interface declaration. Lovely. Okay. Great. So now we have the interface. I'm going to again dive into the AST Explorer. This is pretty much my life when I'm doing work with ASTs, is it's write a bit of code, go back to the Explorer. If I weren't streaming and I had a bit more real estate, I would have this on one screen separate to my code editor and would just be constantly updating it. Can't do that right now. On my other screen, I've got two. The other screen has all the Twitch stuff on it. So we'll deal with that. So anyway, what I want to see is for this interface, once we have it, so once we have this user interface, which is here, this interface declaration, how do we go from there to getting the list of fields that we want? So we have the name. We found the name. We're not really interested in that anymore. Okay, so this members array looks interesting. Here we have a property signature, which in itself has a name, and then it has a type, which is interesting for us here. So string keyword tells us that we've defined this name. This property in the interface is defined as a string. And so we can use that to generate the equivalent JavaScript for that. So let's go in here. So if we don't have an interface, we'll bail now. So what we can now do is, let's say, generate code, generate fields. So in test databot language, fields is the object that you pass in to create the builder. So we'll generate the fields, and let's say for interface. And now we'll pass in the target interface. Lovely stuff. So let's go function generate fields to interface. It's going to take an interface, which we know is an interface declaration. And so I'm thinking here we could return a list of strings where each string is one line, one field that we need to output. To me, that seems reasonable to do immediately. I may change my mind in a bit and change that for something else. But we'll see how we get on. That seems to be about right for me. So I'm going to say const field code output, which will be a string array. It's going to equal an empty array to start with, and we will return that output. So in the middle, what we need to do is go through each interface member. So we can say for const member of interface dot, I'm hoping there's members. So you see here, this is a node array of types. So we have a ts.type element. I don't really know what a ts.type element is. So what I'm actually just going to do is log out the member here. And then what I'm going to do is run the test. I know the tests are going to fail because we haven't implemented it yet, but now I can hit view. Generate fields for interface implicitly has an any type, which normally means I've messed up something. Yeah, that will do it. Okay. Interface again is a reserved word, so we're going to have to say target interface. I'm going to make that mistake so many times. So now we just got fields is not used, that's fine. Okay, so this is our, I think this is our member. So name here, the escape text is name, so that's the name field. And the type is a token object, but what's going to be interesting here is this kind property. So every node in the TypeScript AST has a kind property. It maps to a number, which isn't super useful for us. But for those who were here earlier, we used this ts.syntax kind enum. And if we look at that, here are all the numbers. So we can map from the number in the AST back to this type if we want to dive into this. So I'm hoping, can I say something like if ts.string is string literal? That's not what I want. I want the string keyword, don't I? So is enum member, is member name? I don't really know if member name is what I want here. Let's dive back to this AST. So this name. Okay, so this property signature, this thing here, which does represent, if we look at this interface declaration, property signature is that. It has a kind of 166. So I am going to use that hack. Let's delete that. ts.syntax kind. Whoops, let's do G. There we go. And so it was 166, wasn't it? So it's just a parameter. So I don't know if that's super useful to us. I'm wondering instead if I can literally just ask it for its type. So if I do the member type dot kind, that'll get us the right thing, maybe. So we say if member dot, so it doesn't have a type. That's interesting. I was kind of expecting it to have a type. We can see what it does. We can get its children. Okay, we don't have a whole lot on this TS type element type, so that seems to be we are going to want to do a if TS dot is a property. Is property assignment. Okay, none of that is looking exactly like what we want. Whoops, didn't mean to do that. Okay, I'm going to go back to my syntax kind. I'm going to look for 166. So it's a parameter. So is parameter? Is parameter property declaration? That could be what we're after. Again, what we can do now is we can go and look at this definition. And annoyingly, the definition isn't here. So let's say if ts.is parameter member, and let's just literally log. I'm just going to log out. If I could type is parameter like that, because right now I'm a little bit, I don't really know, and so I just wanted to see. Did we get the is parameter? I don't think we did. No, we just get this node locked out. Where are we logging that? I want to just tidy up. There we go. No, okay, so we're not getting this ts.is parameter. So there was this parameter, was it property declaration? Expected 2 arguments. Node and then parent. Okay, is the parent the target interface? No, okay. So we need to figure out a way to get TypeScript to understand what we're trying to do here. So this claims it's a property signature. So this is where it kind of gets a bit confusing between the different things. Because like there's no property... Oh, there is property signature. Okay, let's try that then. I kind of wish there was a page somewhere in the TS wiki or GitHub repo where it taught us through this stuff. Because it does end up being quite a lot of trial and error. Okay, is parameter is login. So it's actually a property signature, which is a little bit confusing. Maybe I've made a mistake there. If we constant log member.kind, let's see what the member is. Maybe I was using the wrong word. It's 168. So if we look at this for 168, property signature. Okay, so I was looking at 166, which I think was incorrect. Anyway, so that often with ASTs, when you don't know them, if the docs aren't superb or very thorough, it does just end up being a bunch of trial and error, at least for me. Hello to a few people who have joined the chat since I last said hello. Thanks for coming along. Okay, so we know it's a property signature now, and hopefully this will let us do things like member.name.escape text. Is there on there? We know it's a property name, so what do we have on those? Get full text sounds about right. Let's again debug my way to success. Did we log that text? Did that get logged? Can't read properties of undefined reading text. Okay. I vaguely remember this stuff happening before. Let's just look at the kind that this is. I think it's going to say it's an identifier. So I think I need to do something like if is identifier member.name. .log. Member.name.escape text. Maybe that's what we want. We'll see. Name. Okay, yeah. So this is where it can get quite confusing. For example, I'm now trying to think of examples for the TypeScript AST where the property signature member name wouldn't be an identifier. I suppose in TypeScript you can have those dynamic index properties, so maybe that's an example. there'll be a lot of edge cases that we need to tackle as we build out this generator. But for now, I'm going to focus on the positive, nice, happy, easy in quotes path. And so to that end, that's fine. We now have the name. So we can say, yeah, let's say let field name, just have it empty for now. And now we can say field name equals member.name.escape text. Okay, so we have the name. We now need to check the value, which I think is member.type. Yeah, which is its type signature. I'm not entirely sure why that... I need to do it in here, don't I? Entirely sure why that is optional. Again, trying to think of a time where you would have an interface not have a value. Maybe that's to support type checking as the user types in an editor. So maybe they haven't typed the value yet. I'm not sure. So we can say if member.type. So now we have it in here. Is string... No, it wasn't string literal, was it? So we might have to do... Well, let's use our trick. Let's go look at what the type will be for this bit, the actual string. It's a string keyword, and its kind is 150. So let's go... Whoops, what did I do there? Let's go to that and look for 150. See, interesting. So that says satisfies keyword. So this is satisfies is a new keyword that came out in TypeScript 4.9 very recently. So clearly the AST Explorer doesn't have that type. So I wonder if that's why all the type kinds are going to be slightly off. So there we go. It's still using TypeScript 4.7.4, even though TypeScript 4.8 and 4.9 are out. So we have to be a little bit careful there and kind of double check this whole thing. But string keyword is 152. I don't know if I can literally say string keyword. I don't. It's ts dot. No. Okay. Fine. So we can say if member.type.kind is ts dot syntax kind dot string keyword. And this is where it's really nice that TypeScript actually provides this syntax kind enum, because this is so much more readable than like something like that. So that's really good. So we'll say member.type. I guess I could do that, couldn't I? And then ditch this one. Oops, there we go. And we'll say let field value is empty string as well. This is definitely not how the code will look finally, but it will do for now. We can say field value is, we'll literally set it to the empty string. So if the user has asked something to be a string, we'll default that to being the empty string. So name and value are assigned at type never used. So where are we? We're in this loop. Okay, great. So we hit the end of all our checks. Obviously this will be expanded over time. And we'll do field code output dot push field name colon space field value. Whoops. Okay. Fields is defined, never used. I do remember some of this. Can we do have to string that? I think we do. Okay, so now we can say const code. I'm going to do code parts, which will be a string array, and then I'll join them with new lines. I think that's normally quite a nice way to sort of build up these up. So the first thing we're going to push is the actual builder. So we know it's going to be build, and then we pass in the TypeScript generic. We actually know what this is because, oh, that's my Vim going way overboard. We know this is the target interface name that the user gave us. So we do that, and we can do those brackets as well. And then we can do code parts.push, and these are going to be indented in a little bit. So we want to say for const field code of fields. We're going to push in this, but with a couple of spaces at the beginning. Is there a pad start method now? There is a pad start. Pad the current string with the given string. Oh, so it reaches a given length. We don't need that. We literally want to pass in 2. So let's just do that manually. Have I messed up this? I messed up. I don't need that, do I? There we go. That's done that. Code parts, and we're going to return, and then we say code parts.join on a new line. Oh, we need to close off the actual builder call, so we'll do something like that. Oh, code parts.push. Oh, and I've been coding right over my head is right over my code. Thank you. Is that Alex, I think, who's pushed that, who's pointed that on chat? Yeah, let's just pull me over to this side. Great. There I was thinking I'd have code on the right hand side, but instead I've stuck it all on the left. Hopefully that's better, Alex. Thank you. Apologies. I'll try and remember that. Again, please ping if I fail. Okay, so let's run this now. And we're still getting an error, which is a bit of a shame. Okay, so we expected... So this is where this output can be a bit fiddly. But we actually got this, but we expected something that looks a bit different. Did I just mess up my test expectation here? 1, 2 fields. Oh no, I'm not doing the fields. My code is wrong. So we're going to push that. Then we're going to push code parts.push. Indent in fields with an opening brace. We need to push the closing brace there. Again, it's definitely going to be a nice way of doing that. And then in here, we need to push with 4 spaces. This definitely needs some tidying up. Okay, we're expecting... Okay, I'm now going to have to put code over here as well. I will keep an eye on my my face. Let's build user fields. I think we just need... Do we need a new line there? Oh, sorry, a comma there? Oh, hang on. It's because the field value... I'm getting very confused here. The field value is an empty string, but I need to actually output empty quotes within the string to generate the correct code. That's what's going on here. So we'll escape that, and we'll have another one. Oh, ESLint has just changed that for me. Okay, we're still erroring. I'm kind of hoping we might get there in a minute. Expected... Is this the same issue? No, that is... Like if I do that... It still says we're expecting this no name there, which is confusing. I shouldn't have to escape those. I'm not sure if I'm missing... What's on here? We can fix that with a semicolon there. Build user fields. That all looks indented correctly. Field code of fields. I'm just going to jump out of Vim for a minute. Sometimes I like to just run it here. So yeah, this is weird to me that the actual is correct. It has those empty quotes. That's what exactly we want. But the expected value is name with no empty quotes. I don't fully understand why, because I think this should be working. But I'm just going to change that to foo and run it again. My face is just obscuring the task error. Let me just move that up a little bit. There we go. Oh, have I got the expected and actual the wrong way around? Expected. Actual. Yeah, I have. So earlier on I swapped those thinking I'd got them the wrong way around the first time, but it turns out I got them the wrong way around when I changed them, which then means that the test green and red output is wrong. There we go, right. So we are expecting name foo, but we're actually getting name with nothing. So firstly, let's fix this assertion. Task is erroring again. Right, okay, so now we're in a better position here. Because we actually have the tests the right around and I understand what they're doing. And it's this problem, isn't it? So field value initially needs to be empty. If we find a string, we will set the value to be a literal pair of double quotes like that. Might we be green? We might. Wait, we are successful. Excellent. So we have the first test passing. So we can now take this TypeScript type and generate the code for it, which is pretty good. There's one thing here. I'm going to say const user builder. So we'll need to fix that as well. So the way we're going to generate that is we're going to take the just the target interface that the user gives us. We'll downcase it and we'll stick the word builder after it. That will be problematic if the interface is camel cased, because then obviously we will downcase it all. So we'll need to deal with that, but this is all things we can deal with in a bit. Don't need to deal with it right now. So we'll just do that down in the final part. So here we'll say const. I'm sorry, Alex, I've just seen your message about the numbers. Let me put this thought into text, and then I will get back to you. So we'll say target interface name to lowercase builder equals task success. Great. So yeah, Alex, the line numbers, they are what's called relative numbers. So up or down. So you see right now I'm on line 63. So that's why on this line that I'm on, if you can make that out, it says 63. That's the current line number. All the rest of the numbers are relatively positioned. So for example, the line return field code output has a 13 by it. That's because it's 13 lines above where I currently am. The reason that's useful, particularly in Vim, is you can jump by putting a number and then K or J to go up or down. So if I do 13K, I jump straight to it. And I can do 13J to go straight back down. So it can help you navigate because you know how far you need to go. What it also lets you do is, let's say I'm here and I want to delete the next 2 lines. I can do 2DD and that will delete that for me. If you want to do loads like 13DD, it will take all those away. So because so many Vim commands take a number and then the command, you can, at least for me, I'm more productive with relative numbers because I can use those numbers to jump between things as I'm going. You don't have to use that in Vim. There are other ways to do it, but I tend to quite enjoy that way of navigating. I think it's relative number. Yeah, so relative number in Vim is the option. Okay, great. So at this point, I'm going to commit this as well. I use fugitive.n.vim, not nvim. Fugitive has been around for a long time. It's fantastic. It lets me kind of look at the changes and stage and unstage them. I don't want that change, so we'll get rid of that. That change is fine. Here I just like to say first passing test for the generator. So I'm on a different branch. I'm on this generation branch, so I'm not on the main branch. So at this point, I'm not super worried about detailed commit messages. I will try and make sure they're useful-ish, but I will almost certainly do some rebasing or rewording of them when I'm ready to merge this, which won't be for a very long time. Okay. There's quite a few people watching. Again, thank you very much. Really appreciate people popping on. This is brand new experience for me, but I'm quite enjoying it so far. I hope that you are as well. What I'm going to do is I'm just going to pause for a brief second just to fill up a water bottle, which is empty, and then we'll be back and we'll try and maybe implement one more feature, one more test before I probably call it a night for tonight. So thanks for watching, and I will see you in a second. Okay, I'm topped up. So let's see if we can implement one more feature before we probably call it for now. Again, all feedback welcome. If this goes well, I tend to spend an hour or two on open source stuff every week. Would love to get into a routine where I just jump on Twitch and anyone can chat if they like. So this is some basic generation. I'm not going to kind of play with this too much for now. I'm thinking maybe we look at another type of field that we might want to test and generate code for. So I'm going to my generator tests. So we can, I just have this test called generators now. So I'm going to say like generates empty strings for string types. We're going to copy that test, bring it down, and we'll go for generates sequence fields. Let's do sequence for number types. So we're going to name string. Let's actually do a second one just to test it. So we'll do ID number. And what we'd expect here is we're going to have the name will be an empty string, but what we expect the ID to be will be the call to the sequence builder. That's another thing, actually, we're not importing these methods, like the build method and the sequence method, which is built into test databot. We might want our generator to generate those. I suspect we would. I kind of picture you calling the generator and it generating a standalone file for you, and therefore it would need the imports. What we might want to do over time is either generate an import that's like import star as databot from whatever, and then use it as like databot.build. Or more likely what we want to do is want to track the methods that we have used, such as build, sequence, whatever else there may be. And then we could add the import just for those ones. But for now, kind of thing that I won't worry about until this is much closer to being usable. Right now, we're clearly in the very early stages of doing that. Okay, so if we run this test now, we are going to run all the tests because I cancelled the package JSON change. That's fine. They're very quick. So we see here we're not generating the ID field. Well, we are actually generating the name, but we're not generating the actual expected part. So we can go into the generator here. Okay, and again, I imagine that what we're going to do is we're going to say else if member.type.kind, .kind is equal to syntax kind. Is there going to be a number keyword? There is. Beautiful. So one of the nice things about the TypeScript AST is once you know how it works for a particular type, you can quite intuitively have a decent guess of what it might be for the next type that you use. So if we have a number, the field value is going to be this time a call to sequence, like that. I feel like I've messed up my... I've missed an opening brace. That'll do it. So now we run these tests. We might be parsing. We are parsing. So that's a super easy one. Let's do a bit more of an interesting one to finish because that was very straightforward. So let's grab this. So test databot has a one-of generator, which takes any number of arguments and it will randomly pick one. Where that's useful in TypeScript land is if you have an interface that has a union type, which could be a couple of particular values. So let's say it generates one of for union types. I'm going to get rid of these now just because we don't need them. Let's say color, I'm going to go UK spelling, and this can either be red or it can be blue. No idea what this represents, but let's go for that. I'm going to expect that what we end up with here is color be one of red, blue. The only thing I can't remember is if one of takes any number of arguments or if it takes an array. No, okay, it takes any number of arguments. Okay. Great. So if we run this, it will fail. Task errored. That's fine. We're going to be generating color with an empty value. What we probably would want to do in the future is if we don't know what value to generate for a field, to error or maybe leave it blank, leave it commented out. But for now, again, not going to worry. What I'm going to do is go back to the AST Explorer. and we can replicate our code. Could have probably copied that, but there you go. Red or blue. So now we're looking for this value here. So there we go. So we have name is color, type is a union type, and it's going to have a bunch of types within those. This is where we start to get quite complicated, because this is a union type of strings. So it's going to be quite easy for us to pull out the values here. But of course, this could be objects. It could be any sort of type. And then there's going to be certain points where we're going to have to figure out how to deal with that. Or we're going to have to bail and say this is too complicated a type, because if it could be an object or it could be an array, it could be a class instance, could be this or that. At some point where the generator isn't going to be able to handle every single case, so we will just bail and say like, no, you do this. But for now, we will try, for literal types, we can definitely generate that. And again, more complicated cases will come in time. So let's go down here. And what we want to do is, let's go in here, else if, and I'm wondering if there's an is union type. No, there is, member.type. So what we want to say is, if there is a type, and we have a union type, once we now have this union type, if we head back to the AST Explorer, we can see this in itself has a types array that represents all the types within this union. And for now, we're just going to assume, we're going to check they're all literals. And if they're all literals, we will generate the one-of call. If they're not, we're going to generate nothing for now, just as a sort of starting point. So what we're going to say is, let's figure out if they're all literals. And this is going to be, awesome, Alex. That's good. Yeah, I didn't discover these helpers for a long time. The main thing they're useful for is the TypeScript assertion. So they actually say what type the node is. So the TypeScript compiler can give you a lot more help after you make that call. So I think we say member.type.members. So if the member.type is a union, then we'll look at its types, not its members. Member.type.types. Yeah, lovely. Okay, and that is a node array. So I don't think can we filter these? We can filter these. Okay. I don't want to filter that. I want to say every union type member ts.is literal. Can we say is literal? Is literal type node union type member. What you mean about? Oh, that's fine. That's going to be formatted with prettier in a second. Okay, so if not all literals, we're just going to return an empty string. And again, my favorite type of comment, fix me, show an error to the user. Maybe we'll make a very generic field type for unsupported, which just outputs a JavaScript comment or something. What I don't want the generator to ever do is generate invalid code by default that would error and not run. But equally, that does mean we're going to have to be willing to just put our hands up and bail at some point. With AST, things like this, there are going to be so many edge cases that you often have to implement your desired set of features and then kind of leave it and add to it over time as people use it, and you find even more edge cases. So we'll see how we go. Okay, so we'll return. I don't want to return an empty string, sorry. I just want to say. Actually, don't need to do anything there. So let's swap that. If all literals. Whoops. Something like that, that'll do for now. So if they are all literals, then what we want to do is get the values of them. So again, if I dive in here, a literal type, we'll have, so a literal type node has another literal inside it, which is a string literal, and that has text. So we'll just take that text now. Hey Zhao, I think that's how I say your name, Zhao. Apologies if not. Hello, and thanks for dropping in. Okay, so what we want to do is we want to say const possible values, all literals dot, oh yeah, if member.type.types.map union type member. Now we know at this point it has to be a literal. TypeScript doesn't, so I'm going to say if not ts.is literal type node. We will just return empty string. We know that's not going to happen. This really means that I need to tidy up this code. I always think it's a smell if you've checked something up ahead and then you have to recheck it to satisfy the compiler. So I will probably figure out how to rewrite this code. But right now we have a failing test, so my prime objective is to get that passing. Okay, if it is a literal type node, we can return union type member dot literal dot. We don't have any text again, so we're going to need to make sure we do check this. I guess it could be a number, so maybe numbers don't have text. So I do want literal text, so I need to make sure it's a string literal. Is string literal? Yeah, we do a string literal. Lovely. Again, we're going to return empty strings if it's not a string literal, but that's a quite easy fix. We should support like number literals, etc. Else we're going to return literal.text. Okay, so we have all the possible values. So the field value is going to be one of, and then, oh, apologies, just bash the mic. It's going to be one of, and then pass in all the values. So we'll say field value equals one of, open bracket, possible values dot join with comma and a space. And then we need to close that bracket there. And add a trailing comma. Oh no, the trailing comma is added below, isn't it? Okay, let's see what happens if we run that. Errors. Okay, that's pretty good going. I again have missed the fact that we need to add the actual quote. So we need to return single quote like that. And then I think we're going to be passing. No. So close. Okay. I've got an extra. Actual has an extra closing parenthesis. Task success. Brilliant. There we go. So we now have support for that. I keep saying I will finish. I will finish in a second. But let's say it can be red, blue, or the number 5. And this should be able to support that. Where did I start to learn TypeScript? That's a good question. I think I used, is it the TypeScript handbook? Which was kind of unofficial guidance. But now maybe the person who wrote that has joined the TypeScript team. I can't quite remember. Yeah, so it looks like this TypeScript handbook, which I will paste into the chat, is a good introduction. I think that this is an updated version of where I first went. There's also a couple of books I really recommend. Once you've done a little bit, the Smashing Magazine TypeScript book is very good. Have I got it on the shelf? I can't quite remember if it's still up there or not. Yeah, I have. TypeScript in 50 lessons. This is also a good recommendation. I'm sure you can find plenty of YouTube videos and that as well. The only thing I would say is make sure any resources are fairly up to date, because TypeScript has changed a lot. Awesome. First job. Congratulations. That's really cool. And I think as well with TypeScript, using it every day, you will learn it very rapidly. I think particularly, obviously I'm using Vim, but if you're using any decent editor, it will give you really good information on the types and how they're working and any errors. So that's a really good way to pick it up quickly. So I just say pay attention to the errors you get in your editor, and that can go a long way to making it a bit less painful. Yeah, Vim is... so I've been using Vim for over 10 years now. So, and I still feel like I've got a lot to learn. So it's good. You have to be prepared, I think, to put in a bit of upfront figuring it out. But it is, I can't imagine not using it now, but the muscle memory is very kind of ingrained. Okay, so, I don't know if anyone can hear, the dog is on the chair behind me barking in her sleep. So sorry if you pick up those. Okay, so I'm going to switch this round. I'm going to say if it is a string literal, then we want to return that. Else if there is number literal, numeric literal, not number literal, unit type number dot literal, we're going to return. Now we don't need the quotes around it, do we? So union type member dot literal. Is there a text? There is a text field. Else return this, and again fix me log that this is an unsupported type. Let's run that and see how we get on. Success, brilliant. Okay, so let me commit that, and we'll just say basic support for numbers and basic union types, which is definitely should have been 2 commits, but there we go, we'll push it into 1. Great. So, oh, sorry, Joe, I missed your question. Good to build as a beginner. It's really hard to say. I think the main thing I would say is think more about a project that will interest you enough to work on it. At least for me, I always struggled to build projects just because that was a project to learn to code. It had to be something that I wanted to work on. So actually, Test Databot, if we rewound a few years, was my first attempt to build something purely in TypeScript from the ground up and like ship it and support the types. It is been improved a lot. A few external contributors really helped me with the types side of it, but I was excited to build Test Databot, and so learning TypeScript using that was enjoyable. I've tried to build other projects where it's just not a project I've personally been that interested in, and therefore I've not given it the due time. So I think that would be what I'd say. I think don't worry about making sure it's the right size or shape of project. I would say pick something that you're going to enjoy doing. Yeah, like if you pick a project you want to work on, it won't feel like an effort to learn, and it also won't be as frustrating when you get stuck, I would say. Okay, so let's have a look how we're doing. There are quite a few people in this chat. Again, I really appreciate you joining and watching along. I'm going to end the stream there for my first attempt. I only meant to be on for half an hour. I think I've done an hour and a bit, which is an hour 11. That's pretty good going. I would really appreciate any feedback. I'm Jack_Franklin on Twitter for as long as Twitter is around. If you go to there, though, you'll see my link to the Mastodon profile, which is where I tend to be hanging out now. It's I'll put it in the chat, jackf at indieweb.social is where you can find me. I really enjoyed doing this. I would love to do it again. So if you follow me on either Twitter or Mastodon, I will make sure I tweet when I'm next going to go live. And the goal will be to have a regular schedule if you would like to pop on. I will also try and upload them to YouTube too, but this is all a big new experience to me, and I'm just going to kind of see how it goes. So with that, I will wish you all a good night if you're in the UK or further east of me. If you're west of me, then I'll wish you a very pleasant day. Thanks again. Let me know how you found it. Feel free to DM me, tweet me. What do we say on Mastodon? Toot me, Mastodon me, whatever the verbiage is. It was really nice chat to you all. Thanks to everyone who put messages. Alex, Zhao, Paul, much appreciated. Have a great rest of your day. Thanks, everyone.